Hello, Pietro.
Hi, Frederick.
Now we are live, and I would first like to mention a couple of words that we are now here today for yet another seminar in the Connect Them All series. I am Fredrik Ahlgren, and I'm a senior lecturer at Linnaeus University in Sweden. And we are doing this initiative as our small contribution in the field of IoT to every month explore yet another area with yet one other new speaker every month. So within the field of IoT. Please follow us on all platforms available, Twitter, LinkedIn, etc. And we do also have the Connect Them All website, which you might be able to find if you Google, or we will share it in the comments. So those of us that are doing this is Anna Förster from University at Bremen, Marco Zenaro from ICTP in Trieste, Italy, and we also have Pietro Manzoni, which is also the guest of honor today, from University of Valencia in Spain. So with those words, I say very much welcome to you, Pietro. And yeah, I've now shared your slideshow, and you could probably press sort of full screen.
Okay.
Yeah.
So let's see if it works. I'm sharing my presentation. Okay.
Yes, it seems to work.
Okay. So, well, first of all, thanks, Freddy, for the presentation and for being the host of this session. And well, welcome everyone that is watching right now or will watch this presentation. So, the idea of this talk is to try to describe some of the work that I've been doing in my group and with other groups related to what is called AIoT, so artificial IoT or artificial intelligent IoT, and it's used for a specific area, which is environmental intelligence. So, before starting, some indication on where I am and from where I'm talking. So this is I'm from the Polytechnic University of Valencia, and I always like to put a map on where Valencia is because it's not as famous as Madrid or Barcelona. It's right on the east side of Spain, on the coast. And here, what you can see is on the right is the web page of my group. Here is the link and my email in case you want to contact me for whatever question related to the work I'm doing. And again, this basically the group was born in 2000, a lot of years ago, and we were basically a computer networking group. But during the year, we kind of focused on many different applications of networking. And since a few years, I'm specifically working on IoT, and since 1 or 2 years on the application of artificial intelligence to IoT. Okay, so that's enough.
So one quick question here, Pietro. You have been in the IoT field for how many years?
Well, in the IoT, maybe 5 or 6 years.
Yeah.
And I cannot hear you.
Okay, now I maybe only asked a very quick question. Can you still not hear me?
No, I can hear. Yeah.
So thank you.
No,
Don't let me disturb you. I might add things during the way, and also to be very clear, if you have any questions, those of you that are watching, I'm happy to take them in the comments. I will bring them up directly with Pietro. Okay.
I don't know why sometimes your voice, I see you talking, but I cannot hear you. So I don't know if my problem or is a more general problem.
Okay, I need to. I don't know either. So if you just continue, I will check.
Okay. So if you want, so let's first. I'd like to first describe what is meant by environmental intelligence. And so the first step is to talk about environmental sensing. So environmental sensing is, as you all may know, Internet of Things comes from sensor networks. Okay, so we used to sense things like temperature, humidity, or whatever parameter, whatever value, and bring those value to a central node and to collect that information and to take decisions. Okay, so IoT is kind of the evolution of sensor networks, and the idea is combining sensor network with the internet. And this allows to do this data collection, evaluation, presentation, and analysis in a more kind of complete and extended way. Okay, so this picture is simply a kind of way to describe this activity. So this is what is called environmental sensing. So the next step is something that is happening since a few years, and it's about environmental intelligence. So the idea is not only to add or to evaluate the input coming from devices, classical sensor devices, but to introduce more advanced devices, but more in general, whatever type of data source that can help what they call decision makers, politicians, people in charge of the management of some specific area, for example, to take decisions. And not only that, but take decision and evaluate whether those decisions actually obtain the desired results, and if this is required, improve the action that are taken. Okay, so it's basically an evolution of environmental sensing. And in this sense, there is not simply IoT. So, and there are other technology. Later, I will show some of them. I will indicate some of them. But artificial intelligence is a growing. Maybe technology is not the right word, but it gives a strong support to this decision-taking process. So why I'm talking about environmental intelligence? I'm talking because since a couple of years, we started this project in 2021. Yeah, and I'm involved in this project, which is called Smart Lagoon, and you can see the countries that are involved in this activity, in this research. And the basic idea is, as I said, to analyze a specific location, which is here in Spain. Now I'll show you a map, and you will see where it is. Which is basically a natural lagoon, and try to include as many parameters as possible, like social networks, like the opinion of the citizens, satellite inputs, and try to bring all this information together so that we can kind of see interrelations. So what affects what? And so decision maker can use this information through a tool that I will describe in a few moments to take decision and hopefully to improve the situation in this context. Okay, so if you want just to take a look, there is a nice web page where you where you can find more information. So let me first describe this the context of this project. And the context is what is called the lagoon of Mar Menor. So here you can see on the left side kind of a map so that you can kind of locate where it is. It's basically where the red arrow is located, and it's around 300 kilometers south of Valencia. It's called Mar Menor because they consider that the Mediterranean Sea is the bigger sea, and so this is the lesser sea. So Mar Menor in Spanish means lesser sea, so something a small sea. And it's actually a saltwater lagoon, and it's said to be the largest saltwater lagoon. People in Venice, they kind of disagree because Venice lagoon is also, they say that it's bigger, but it's a different type of lagoon. But this lagoon is quite big, so you can see the numbers: 135 square kilometers and coastline of 73 kilometers. And what's the problem with this area? So this area is surrounded, or it's what is called, the technical name is highly anthropized area. Anthropized means that the effect of humans is highly evident in this area. Which are the three most relevant activities? And you can see here on the right. So there is tourism. There are a lot of hotels, restaurants, bars, and a lot of people go there to have to do their vacations. There is fishery, people fishing in the lagoon, and all this lagoon is surrounded by agriculture. And sometimes the interest of these three main entities are in contrast. So because agriculture will take care about their crop, and to get a better crop, they have to take some actions. Those actions can impact on the lagoon, and that impact cannot like the tourism. At the same time, tourism does not go very well with fishery, because they kind of modify the structure and the environment in the lagoon. So, but again, there are three completely legal and very active human activity. And so what we need, one of the goals of the project, is to analyze how, if we can find a way to have all this activity, human activity, to coexist while keeping the environmental area, that environment, safe, or preserve its characteristics. I put these slides to show some of the problems that affect this area. So probably the worst one is what is called here, you see on the right side, what is called eutrophication. Eutrophication, and it's a problem that derives from what the agriculture kind of use on their crop. That goes through the rivers down to the Mar Menor. Since the company, what the people that work in the agriculture are putting their crops, helps to the crop to grow. That same product gets into the Mar Menor, and so the algae and all the nature inside the Mar Menor grows. This needs oxygen and uses oxygen, and takes the oxygen from the fish, so the fish dies. So there is kind of an indirect, which is kind of direct impact on an agricultural activity on fishery, and also on tourism, because at the end, if all fishes die, fishermen cannot fish. But imagine going on a beach and find a lot of dead fish is not kind of the best way to have a rest and enjoy the sea. So I think this one probably one of the worst effects, and there are images from 2019 that are incredible. I mean, kind of impressive. The other part is what is called on the left side. It's called cold drop off, and the translation cut-off flow, which basically in this area it either doesn't rain or it rains a lot. So it may rain 2 days per year, but during those 2 days, a lot of water is falling down from the sky. So, and this creates, you can see from the picture, that everything that is on the ground is kind of carried into the sea. So creating, again, more pollution, and beside the effects on the population that lives on the coast. So these are the two main problems. And so that's why we started to work on this project. And the general objective is another idea, which is always is older than, or basically coexist in time with IoT, and it's what is called digital twin. So digital twin is another interesting technology, let's call it this way, and it's a way to get to kind of create a copy of a machinery, a national scenario, use the input that comes from all the possible different sensors, and create a replica. And on this replica, do all the possible evaluation that could be required to implement strategies on the actual scenario. So here there is, I'd like to spend a few seconds talking about digital twins. And I think this image is kind of interesting. It's from a very interesting paper. You see the reference down there. And so there are various definitions of digital twin. You see I put the one on top of kind of an official one from the Industrial Internet Consortium. So it's a digital representation of an entity, including attributes and behavior, sufficient to meet the requirement of a set.
And also, Pietro, just to add to that, I was curious about another interpretation. So I asked ChatGPT, and it actually gives more or less the exact same as you showed here. Virtual representation of a physical system.
Yeah. So now everyone works with ChatGPT.
Yeah. I had to introduce it.
Yeah. So yes, so and it's, I think it's digital twins are an interesting tool. So and I think also this picture allows to give kind of how digital twin gives an evolution to IoT. So you see, on the left we come from past states. So we want to log history and keep memories of what happened. Okay, keep data of exactly what happened, so that from that data we can infer the present state and the future states. So we need to get a lot of data. We need to create historical data, but at the same time, we want to know what's going on now. Okay, so we need to have kind of real-time information about what is going on right now, which is the temperature of the water right now. Which is the density of salt concentration in the water right now. Okay, because this allows us to take decision right now. And then there is another interesting part, which is where is machine learning, artificial intelligence comes, and where is being heavily used, is to predict. Okay, so we know the history, we know how it is right now. So the idea is to create models so that we can forecast what will happen if we keep doing if we don't do anything. So what will happen if we don't do anything? But through the digital twin, what we can do is, okay, let's see if we change this factor. What if we change this other parameter? What would be the possible future states? And I think this is the very interesting part, because this is where decision maker can use this possibility to evaluate what they could do that would not kind of put in danger the activity of any of the, for example, the three main activities that I mentioned before.
So Pietro, generally, how long time spans are we talking with these kind of systems, like historical data, before you have like the chances of getting a representation of that system?
The longer, the better. I mean, the worst thing is to take decision based on maybe 6 months, 1 month, or 1 year. The ideal situation is, okay, let's create an historical track of the behavior of a certain scenario, and the more data you have, the better your future prediction can be. So this is kind of generic criteria with machine learning. In machine learning, when you are working with a neural network, the data set is crucial. So if your data set is a well done data set, is a complete data set, then your neural network will be properly trained, and then the decision or the inferences that you will take will be correct.
Yeah, and also when we talk about digital twin, and you mentioned now machine learning and AI, can it also be like white box modeling, like based on mathematical and physical equations, or?
It can be whatever you want. I mean, yeah. You have the data. You can simply visualize them. But on having the data, you can apply, from Markov chains or neural network, deep learning. I mean, the interesting thing of this part is collecting the data, but as I will show you in the next slides, data not only related to physical sensor, but data related to as many sensors as possible, so that you can apply whatever predictive technique you want to try to the data. Okay. So I think that's the interesting part. I mean, what I'm saying, yes, I don't want to give the impression that we have to use neural networks. Okay, so it's up to anyone that wants, because at the end, for example, in this case of the project, all the data that we will collect, we will public. So that will be a kind of a very large amount of data that will be open, and anyone that wants to test a model and compare the prediction of its model with the other models, I mean, it's very welcome. Okay, so because at the end, the modeling part is the most difficult part, because I mean, forecasting the future is is a complicated task. But if you don't have the data, if you don't have your input, proper input, and the wider input as possible, and if you see from the next slide, I put some notes on this same picture. So we need to provide as much input as possible, because we need to have we have to keep track of many interrelated sources, and use those sources, as it says on the right part, creating models, discovering correlation, using I mean, many techniques. In this project, there is environmental scientists, there is a geographer, there is people that work in social science, there are computer scientists, and the idea is clearly working from a different point of view helps you to kind of see the problem from different perspective, and probably finding the better solution. Okay, so so I think this graph kind of summarizes a little the idea. So what I wanted to show is some of the sources that we are using. Again, it's a project where we are there are 8 members, so it's not simply something that we are doing here in Valencia. It's kind of part of the project. There are classical physical sensor. There is, for example, you see there is a buoy that is being used, and it took 1 year to deploy this buoy in the sea because of a lot of more bureaucratic than technical issues. Sometimes bureaucracy is not helping science. There is classical remote sensing. Satellites are a growing tool that is being used to monitor certain areas. They don't provide, for example, the same granularity. So sometimes satellites can provide you information about very big zones. And if the climate is not proper, you can lose some information, but it's another source. We are using social sensor. Social sensor means Twitter, Reddit, kind of data streams, Telegram bots. And there is a group that is working with linguists to look for pattern in these sources of information of social. We call social sensor. They are social application to detect whether someone is seeing a problem and is raising this problem in this social network. So, and we want to compare those facts with the other input. Then there is citizen science. You see on the right one of the activity that has been performed with the students of the primary schools. The sea that you see behind is the Mar Menor, and people is the two kind of those are 2 PhD students. They are kind of explaining the problem, getting the students to give them feedback, using some strategies to involve them by painting, by doing some interview. And this gives another point of view. Okay, and there's crowdsourcing. Crowdsourcing is kind of another classical approach, is again kind of related on putting the user or the citizen in the loop and getting information. And all this information is what is provided to the digital twin. So I get some picture. This is the buoy we got. Is kind of 2 meter and something tall. It's very heavy. It's connected through GPRS, LoRa, and I mean it has a lot of sensors. And
Pietro, you talked about this lagoon, and it was quite big. So, do you have LoRa reception even like in all areas of the lagoon, or?
Yeah, we installed the there is on the top part of the lagoon. We put a LoRa antenna. We are using LoRa, not LoRaWAN. We are working on efficient protocol based on purely LoRa, because the problem with LoRaWAN is that the data that we were collecting, for example, from this buoy, was kind of a huge table, well, big tables, a few kilobytes. So LoRaWAN was not the best option. So we created our own protocol based on LoRa, and we installed an antenna on the northest point of the lagoon, and we are getting data from that. So the link is about 14 kilometers, and you see the antenna here. You see in the picture on the left, the white antenna is the LoRa antenna. And internally there are the different sensors. There are batteries. And well, we are measuring chlorophyll, salt density, oxygen, temperature. I mean, many sensors, many kind of physical parameters. The other interesting part is about monitoring the influx of water. And as you can see with the picture on the left, you can see the traces of the rivers that are ingoing the Mar Menor, and you can see there is a very wide network of incoming rivers. And the problem is that these rivers can either be kind of empty most of the year, or they can overflow in very quickly. And so the variability is very, very high. So what we deployed is we are deploying actually a set of cameras. You see one fixed on the right, and what they do is analyze the water and measure the actual inflow of water in real time. Okay.
But Pietro, it's interesting that you used camera technology for this. This could have also been done with the like other kind of sensors, I guess?
The advantage of camera, now I have a short video that shows you how it works, but this, there are other techniques, but the advantage of this is that it is not affected by, I mean, it's not something that you physically have to put inside the water, which is actually the source of malfunctioning, and it requires a lot of maintenance, because, it's in the water. If a rock hits that device, you have to go there and fix it. It's with IoT and in general, or with sensor, whatever type of sensor, you want to leave it there and forget about it. So the ideal sensor is something that works without any intervention or very rare interventions. Okay, so we consider putting something inside the water, but again, this would have created maintenance problems that we wanted to avoid. So the cameras, they are all external. They are connected for the moment with 4G, but we want to connect them also through LoRa. And the advantage is that the maintenance is much less, because they simply are based on cameras. And you can see here some of the images that we can have. You can see we have real time an evaluation of the flow of the water, the variation in elevation. See, for example, in the center picture, it's 0.48, and and we can do already some prediction of where the flow was about to go, and the intensity of the flow. So a lot of parameters. And the interesting thing is, so you can see here, I don't know if you can see clearly in the image, there is a video that shows how this can be obtained in real time. You see and you see, for example, the image in the center, more or less, see that the variability can be quite high. You see, it's almost from no water or just a little of water, which is here, up to here where it overflows. Okay, so I mean, I think also this is another reason for having this sensor outside. And this,
Pietro, this is all done on the device. What you show here.
Yes, this is what we are doing here is doing processing on the edge. So it's the camera. There is at the moment there is a Jetson Nano, device there that is doing the processing. We are trying to test with kind of less energy expensive devices, because at the end you have to power them. And at the moment, as I said, the connectivity is through 4G, but the idea is to kind of summarize all this value that we get from the image and send them through LoRa to this protocol that we developed. And but again, this is a compromise, no? Because with LoRa you have very low bandwidth, and in this case sometimes we have a lot of information, so we are looking for technique to compress this information and optimize the data set. But I think it's interesting because it allows to kind of have a clear evaluation of what's going on and on these rivers. The other part, so this is these are through fixed cameras, and related, if you remember from the first slides, we have what we call crowdsourcing. So we want to allow users, citizens, to provide this information using their smartphone. So we provided, well, one of the partner of this consortium defined this application that runs on a smartphone, and that can provide the same information, and that can kind of upload this information into our data lake, and kind of create more input to our. So I have this short video. It's 1 minute. So just to see how this could work. As you see, there are some marks here in the water that are required by the protocol. So the idea is to simulate a citizen that goes there, see that the water is rising a lot in a certain area, can take the application, and what it can do is, okay, start filming that area. You see those mark in red now, so it's recording the video because it wants to send this input. Now what it has to do is to select these marks because it's required by the software, and so the application will now start. Well, it evaluates what it has to give the input of which is the water column, which is the level of the water in this moment, and so it says process video. So it's doing the process locally, and what it does is, okay, it provides, as you see below, there are water column, the velocity, the discharge, so input. So we can upload this information, and what it says is send this information to our digital twin, and this is considered as an additional input. So, and this can be done by anyone. So, well, this is the link of this application.
So are there many more using this application, I guess, or?
Yeah, we are distributing this application to the citizens that are living close by this area, and we are accumulating this information on our digital twin. But not exactly the image, but you see the values that were extracted by analyzing the video that were uploaded. So another input, maybe I can go a little faster here, is about, we are also including satellite, and you see you're using the classical Sentinel and satellite to evaluate this information, and simply you can see here that on the right there is kind of a dynamic image where we can see, for example, there is a light green kind of spot on the left part of the Mar Menor, and which was an intrusion of some pollutant into the Mar Menor. And what we can see is on the left are some correlation that can be extracted from the satellite about the temperature, about the presence of chlorophyll. Certain parameter can be estimated, not with the same exactitude as in situ devices, but I mean, they are additional information that can be combined. Okay, so so we have a lot of inputs basically, and all this input is being introduced in this digital twin. I think I'm running a little late. I wanted to do a short demo, but maybe it's I don't know if I have time.
Maybe we have time. I think you showed me a little bit earlier. It was very interesting, so I think it might be worth showing.
Yes, let me just switch. Okay.
Yes, we can now see.
Okay, so this is the digital twin. So you sorry, there is a lot of Spanish and mixed in. So anyway, but the concepts are more or less the same. Let me. Oh, nice. Okay. So here you see the map, and you can select information and click on this value and obtain this information. You can go on the cameras. For example, another input is weather forecast. We can add it. We can add satellites. This is the buoy, and so if you click there, you can see the current value of the device. You know, the concentration, O2 concentration, temperature. So now there are 10 degrees there, and you can have the values at different levels. Okay, so you can inspect the value. At the same time, you can do the social sensor, what people is talking about, which are the number of publications every day, how many messages. This is the sentiment of the publication. Is people happy what is going on in those areas? Is very positive. Is neutral. So you can see there are different perceptions of the problem. And words cloud to see what is kind of, you know, the word that is more evident, and so which basically is what people is more worried, or at least what people is more talking about. Okay.
Yeah.
And here you see more from, for example, from Twitter. You see well, rain, contamination, agriculture. So you can get all this information. And the nice thing, let's see if I can, so you can see the data, for example, like this. And you can see the evolution. For example, remember what I said before about the digital twin, that you need to have the current value, but at the same time, you want to have the evolution, what happened, the history. So because from that you can forecast. Okay. So here you see, I mean, again, consider that it's an ongoing project, so there are values that are present. Sometimes they start working, and so I mean, and the interesting thing is that we can do a comparative graphics with, for example, you know, the value of the temperature with you know, what people is talking about hotels, or what people is talking about you know, water irrigation, or I don't know, contamination. Okay, so you can see, you can plot the different values, and you can, for example, include the value from camera, the value from satellite, and again, see that there is some correlation. Okay, so at the moment it's visual, but the idea is we have the data, and you can create this machine learning based, artificial intelligence based mechanism, which is one of the tasks of this project, to find this correlation. So, for example, to forecast the evolution of, for example, the chlorophyll with respect to, I don't know, the number of tweets related to something. Okay. So this is the general idea. I mean, the tool is open. So if let me switch back to the slide.
You're able to actually access this data. Anyone is, or
yeah. It's let me show the slide. It's here. Yes, you can. There is the link, and you can access and play with the values. You can try it out, and I mean,
so the advice is, instead of, if you would like play around with machine learning projects, instead of going to Kaggle, you should go to more sensing and download some data.
Yeah. I mean, this is related to a specific location, but I mean, it's I think it's an interesting project. It's, I mean, again, it's a research project that we are beginning, and I mean, but I think it's interesting the fact that you can access the data. Allows everyone to do its own analysis, evaluation, can provide feedback. This should be improved in this way, this other way, and maybe this correlation is more interesting than this other correlation. For example, this is an example of the impact on chlorophyll, on the increasing number of messages on RSS, on Twitter, and if we combine this with the image from the satellite, so we see that there is a correlation between the increasing chlorophyll, the images from the satellite, and the tweets from locals. So there are correlation. There are ways to obtain some clear forecast combining different sources. Okay, so this is basically my idea was to describe this project. Again, it's an ongoing project. You can take a look at the web page and see. And again, the idea is to have data, and what we are doing is create models. So this part is how to provide more models, and this is another part that we are investigating, we are working on, and this is more specifically called the artificial intelligence of things. And well, you saw already something related to vision AI. This is something that we are doing. We are kind of starting to use some edge computing, for example, with the camera. In the buoy, there is some pre-processing of the incoming data. And TinyML, I don't remember if there has been already a talk related to TinyML in this series. I'm sure there will be.
Yeah, definitely will.
Yeah, there definitely will be. So and TinyML is part of this family. It's part of this family. The characteristics of TinyML is that we are doing machine learning on well, the definition here is battery operated devices, which means kind of devices that are not extremely powerful, but still can provide some inference using the input. And this allows to, it has a lot of advantages. We can use more edge computing. We don't need, we can have some more privacy on the data. We don't need kind of strong networks. And I mean, there are various different advantages. What can be done? I mean, not specifically related to Smart Lagoon, but I put here some of the examples. The artificial nose is something that I never tried, but I like to try it. It looks like it's possible. And the idea is here to find the idea also of AIoT and TinyML is to use cheap devices. For example, air quality reporting can be done using very cheap and low power sensors, integrating them, do some processing, local processing, and sending the results. Cameras are being used a lot. We, more specifically in the group, we are we are using a lot, and I'll show you in the next slide one application. And also microphones are used a lot, being used a lot. Sound and noise. For example, in another project, we are developing a tool that detects the presence of cats. Why? Because in that specific natural park, there are a lot of birds, and it's a location where birds should be preserved. But it's surrounded by a lot of, regular people living with cats. So cats, they are hunters. So at night they go there and and kill the birds. So, which is, it's not part of the way we want to preserve this natural park. So they were interested in detecting cats and try to see where they can stop or not letting them enter into the national park, for example. Again, related to this natural park, what we want to do is detect by using microphone the specific species of bird that are present there, because there is a lot of tourism that wants to see specific type of birds, so we can detect them. And then for example, I like this tool, the speech chat by Peter Warden, which allows in a Raspberry Pi to translate from voice to text and can allow to do interesting sensor. Now I'll show you an example. So here is one of the example. One of the things where we are interested in this environments in natural park and the Mar Menor, they are to evaluate the impact of people. So there is this is an example of with a very simple device, which is a Nikla Vision. You see the size. I put the pesetas, but anyway, consider that's kind of the size of a €1 coin. So I don't know why I used the 100 peseta. It was nostalgic.
Yeah, nostalgic. Those were the good times.
yeah, the old times. So, but again, you see the size is very minimum, and you can see here that I have a short video where this allows you to count people. So it allows to continuously monitor an area and count the number of people that is entering, so going from right to left, and then exiting, going right to left to right. And the advantage is, as I said before, there is with this type of solution, privacy. We are not sending the image of anyone. So we are basically simply detecting that there is a person and that person is moving in one direction or in the other. And as you see on top, there is a number. I know the number is not precise, but it's not easy to detect people where they're moving that type of way and with this device. So we have an estimation of the number of people that is entering and exiting. The next step, what we are doing right now is counting people walking and people going by bike, because there are two different type of users, and we are managing to distinguish people entering by bike and by walking, and we can provide this information, again maintaining the privacy without the need to send in video, just counting and sending periodically a number. So during the last 2 minutes, 20 people enter, and 5 people went out, and 3 of them were a bike. Okay, so we can use LoRa 1 or NB IoT, very low bandwidth technology. We don't have problem of privacy, and these are kind of cheap, so we can put as many as we want and have this input from many different locations. The other thing that we are doing is what is called sentiment analysis. To do this, we are using Portenta, which is a nice device by Arduino, and it has 2 microphones and the camera, and can be connected through LoRa. And the idea here is to use, again, machine learning that runs in the device that details. I'm sorry, the words are in Spanish, but this is nice, very nice, bad, sweet, very ugly. So that kind of words. And the idea is to put some of the devices in some location of the park and of the Mar Menor, where tourism is going, and by listening to this word, kind of have some input on the feelings, on the sentiment that that specific area is generating. So imagine that you are going on a beach and there are a lot of dead fishes. So if you can detect those words, you can detect have, or at least have another input of that specific situation. Again, as I said before, privacy respected. We are not saying who's saying what. We don't need big bandwidth. We simply say, okay, we during the last 2 minutes we have a majority of positive words or a majority of negative words, and this again it's another input in chip provided by chip hardware based on artificial intelligence integrated using IoT technologies that provides input. Again, this is to give some idea about these slides. I think it's still valid about what we can do with the current hardware. Okay, still doing, for example, video classification. We need Jetson Nano, which is, if you remember, when I said before what we were doing with fixed cameras about the river. So we need more powerful devices. We are working on. I have colleagues that are working on try to kind of obtain better results with cheaper or with less powerful devices, Raspberry Pis, and then maybe some Arduino device. Okay, so to conclude, the next step. So this is something that I wanted. For various reasons, I was involved in the metaverse, and the metaverse now is kind of the new trend. Everyone is working on metaverse, but I think it can, if not the metaverse, there is one area which is I found it very interesting, which is called augmented AIoT. And this is kind of a combination of physical world, digital world, and virtual world. And the basic idea is to offer the way we offer this information. So with augmented reality, we can provide the information on top of the actual environment and create augmented world where the user can get the information directly. Okay, and I think it's so the basic idea would be the basic idea for the moment is, which is not very novel, but the idea is to have your smartphone, you look at the lagoon, and you can get using augmented reality input that is coming from the lagoon with, for example, the quality of the water at that moment or whatever. Okay, so this is an interesting area. And here is there is an evolution in, if there is sometimes a lot of hypes with different words, so metaverse, and now there is the 6G, and they talk about Internet of Senses, which probably would be the evolution of environmental intelligence, and where the physical worlds and the digital worlds are mixed. And I don't know, this is the future. Actually, the paper is by Ericsson. It's an interesting document, and it's called the Cyber Physical World of 2030, so a few years from now. But again, it includes, as you see here, different technology are being evaluated, information-centric networking. I mean, you can see here many of them. And it's I think, fascinating area, very growing area, with a lot of possibility and a lot of work to be done. And yeah, so this is basically what I wanted to talk about. So I put the last picture of the buoy because it took a lot to make it real. So I
So maybe you had more slides on the actual communication, but we actually got the question, and I also had the same question. But you mentioned that you developed your own LoRa protocol, so you're not using LoRaWAN, and we know that using LoRaWAN is quite limited in the amount of data that you can send. If I do remember, is it 56 bytes, or what's the maximum package size for?
But with LoRaWAN, it depends on the spreading factor that you are using. So with spreading factor 12, I think it's around the value you are saying. with
Yeah,
spreading factor 7 is 255, more or less.
Yeah, but still you're quite limited. So could you elaborate a little bit on that?
Yeah, well,
I could put the slide down, and you might be able to.
Yeah, if you want, I add another slide. But anyway, the basic idea here is that we use LoRa, and we use the advantage of LoRa. So basically, LoRaWAN is on top of LoRa, but you can access directly LoRa and use it. So LoRa basically you can consider it as UDP. So it's basically you send something and you pray.
Yeah.
And you pray that it will get to the destination. So in the case of LoRa, the size is limited. So again, the number are spreading factors. With spreading factor 7 is 255. With spreading factor 12 is 50 something. So what we did is, on top of LoRa, we created a protocol that could handle the transmission of a content of whatever size. We tested with, I think, 10 megabytes. It takes forever. And with spreading factor 12, 10 megabytes, I think it was 12 hours or something like that. I don't remember. So it's huge amount of time. But this handled the creation of a session between two endpoints. It handles the data flow. It handles retransmissions. What we added is the possibility to do some mesh. So if your node is not directly reachable, but is reachable through a few hops, it can be reached. We are introducing. We are testing the possibility to increase dynamically the spreading factor if we see that the quality of the link is not the idea. So we have a lot of retransmission. So the first attempt is increase the spreading factor and up to 12 to see if this increases the performance of the link. And the other part that we are using with this protocol, because it's something that still happens in LoRa and with LoRa devices, is that there are a lot of devices. We used to work a lot with devices by PyCon. Now we are using a lot of devices based on ESP32 by TTGo, and I mean there are many of them. And the problem is that depending on the device, you had to kind of reprogram everything. So we are making this protocol modular so that you can use combination, like for example, the processing on a Raspberry Pi and the sending through a LOPI, PyCom LOPI, or Raspberry Pi and the TTGo, everything on the TTGo. I mean, you can, through modules, you can configure your system and get this kind of endless, infinite amount of bytes flow of data between two devices.
Sounds really interesting. So, is there any more information people can find this? Do you have a repository?
Yeah, there is a preliminary version. I don't know where I can send this information. Maybe I can add it in the YouTube channel. Maybe in the comments I can add the link. I can add the information there. There is a first version which is called LoRa CTP, which is LoRa Content Transfer Protocol, and then we are working on another one which is called Allora. Allora in Italian means when. It's a joke, and it will be released very soon because since it's part of the European project, there are some the copywriting and
it's issues. Always bureaucracy.
Yeah, there's bureaucracy, but I mean it will be made public this month or the next month. So it will be. I will put the link, and if anyone is interested, or if anyone is interested, can send me an email, and as soon as it is available, I can send the link to it. So no problem.
We got another question here from Andreas, and he asked about sentiment analysis. So I mean, essentially, how well does it work when people talk in noisy areas? Are you able to pick up those words?
We did some testing. Distances must be kind of close. So we tested up to 3 meters with different type of background noise. So noise is not the problem. Direction, position with respect to the microphone is not a big problem. The problem is, you're not typically saying single word, okay? You're typically saying, oh, look, how awful is this place, no? So the ideal is, the problem we are finding is that catching the word inside the speech. So because it's basically the device is continuously monitoring, evaluating. So listening and understanding what it listening and understanding what it listens. So if the word is not right in the window where we are listening, we may miss that word. But
you mentioned also tourists. Like, are you talking about Spanish tourists, or I guess the language model?
What we are doing now we are trying to use Spanish and English. We are adding both. So, because again, these parks are now in Spain, but there is a lot of tourists from England, from people speaking English, and so we are combining, because at the end it's a matter of having a lot of samples of the different words and say, okay, this word is positive, this word is negative. So at the end, we are basically saying, okay, we detected these words in which are positive and this amount of words which are negative. And so for the machine, for the neural network, the same if you say nice or if you say bonito. So at the end, if you say those words means positive, so it's enough. In any, so the problem that, again, the problem that I just mentioned, that finding the right, so locating the words while it is pronounced. That's why we are moving to using the tool, the speech chat by Pietro, because there we can take the test and analyze the text. So that's probably will get much better results. I mean, there are compromises. We need a Raspberry Pi. We need a more powerful device for this other approach. In this other approach, we could use a Portenta, which is more lightweight device.
Yeah.
But again, it's a matter of the precision that you need on the result.
Yeah. Yes. We are already at over an hour. And I must say that's been super interesting to hear. I actually missed a couple of minutes in the beginning because I think it wasn't my end. I had some problems with my my mic. But anyhow, like, I think the area like the lagoon, what you talk about, I guess that this is a problem that, I mean, obviously we in Sweden, we live near the Baltic Sea, at least we on the East Coast. You generally say that this is the most polluted sea on Earth. Yeah. So do you have any, is there any links with this project with other areas in the world that have common problems, or is this confined project as it is now?
For the moment, no. For the moment, we are focusing on this specific. The idea is to, because doing this research, we found out there are a lot of lagoons in Europe and everywhere. In Italy, well, for example, the Venice lagoon, it has its own problems, but there are lagoons everywhere. So one idea would be to see that, but every lagoon, every context has its own characteristics, because there are lagoons that are isolated, basically, so they don't have this anthropization, so the humans did not affect them too much. And so I think in Europe, this one is very specific because it has these different sources of problems that are combined. So, but again, yes, one idea would be to compare our results or try to export our results to other lagoons. The problem is that the model that we get from this lagoon can be directly be used in other lagoon. Okay, because every lagoon can be a different situation. So again, the 3 steps on collect information, having information real time, and then kind of adapt the models. It's something that has to be that has to be done. But I think one of the interesting results of this project is the methodology. So we are actually doing a lot of errors and, for example, synchronizing the input. What if a certain type of input is missing? Which input is useless? Which could be interesting? So I think we are learning a lot on a methodology, on defining a methodology on how to do something. And I think this will help future deployment.
Oh yes, very much. Thank you very much for this interesting session. And I think we all of you that have joined in, I think we've learned a lot about lagoons as well, and also being able to get an insight on all the data, and like also that it could be one good takeaway. Like if you're anyway working on any kind of machine learning project and want to explore some data, why not explore some real use data when actually, not the Titanic data set from Kaggle, which is
definitely.
okay. We will. I think we have some. Yeah, exactly. I put a little slide here. The next talk in this seminar series will be the IoT and the two sides of sustainability with Carlo Buono. And you should check our website, connectthemall.net. And you are also able to follow us on Twitter and on LinkedIn. I hope I didn't say too much. Otherwise, we have to create a LinkedIn account. So,
yes,
but
Twitter,
I think that's good.
Yes, Twitter and I think no, I don't think, I don't know LinkedIn. Yes, I think also LinkedIn. I think also.
Yeah. Otherwise, we'll have to create one. Okay. So, thank you very much. Goodbye.
Thank you, Frederick. And anyone, if is interesting, please. There is my email address in the presentation. Please contact me, and I will answer to any doubt you might have. Okay. Bye, everyone.